Bismillahirrahmanirrahim. In this session, we will discuss gas laws using absolute temperature or Kelvin scale. The gas laws can be stated in a convenient form for calculation. In figure 2.112, the volume and temperature graph passes through the origin if temperatures are measured on the Kelvin. That is, if we take 0 Kelvin as the origin, we can then say that the volume is directly proportional to the absolute temperature. So temperature is double, the volume will be double. So volume and temperatures are directly proportional. So on removing this proportionality constant, so volume is equal to constant into temperature. So on rearranging this T from here to here in the denominator, or dividing with T on both sides, then we get this V upon T is equal to constant, and this is called the Charles law and may be stated as follows: the volume of a fixed mass of gas is directly proportional. The volume of the fixed mass of gas is directly proportional to the absolute temperature if the pressure is kept constant. If the pressure is kept constant, then volume is directly proportional to the temperature. So this is called Charles law. And pressure law, if in figure this, we can say similarly from this 1.12, this figure we have discussed already. This figure, if we can say that pressure is directly proportional to temperature. If we increase the temperature, the pressure will increase. So pressure is equal to constant into temperature, and dividing on both sides with capital T, then become P upon T is equal to constant. The pressure law may be stated as follows: the pressure of a fixed mass of gas is directly proportional. The pressure of a fixed mass of gas is directly proportional to temperature if the volume is kept constant. If the volume is kept constant, then this pressure and temperature has this relation, and from this we have PV is equal to constant, P upon T is equal to constant, and on combining the laws, Boyle's law and Charles law and pressure law, then the three equations can be combined, giving this. This is pressure law, this is Boyle's law, and this is Charles law. Charles law, pressure law, and Boyle's law. By combining equation 1, 2, and 3, we can write that PV upon T is equal to constant, and for cases in which P, V, and T all changes, we say P1, V1, and T1 to P2, V2, and T2. Then P1, V1 upon T1 is equal to P2, V2 upon T2. This is called gas laws. And now we put this into practice on page 96. A fixed mass of gas has a volume of 9 centimeter cube at a pressure of 1 into 10 to the power 5 Pascal at 27 Celsius. The temperature is this, volume V1, P1, and this is T1. So T1 is equal to 27 plus 273, because this temperature should be in Kelvin or absolute temperature. So this 27 plus 273 is equal to 300 Kelvin. Similarly, find the pressure. We have to find the pressure when the volume is compressed to 5 centimeter cube. This is 5 centimeter cube, and its temperature rises to this. Temperature is increasing. So this temperature 37 Celsius plus 273 is equal to 310 kelvins. So PV upon T is equal to constant, P1 V1 upon T1 is equal to P2 V2 upon T2. We have to find P2. So P2 is equal to P1 V1 upon T1, and this T2 multiply here, P2 in the denominator, or V2 in the denominator. So P1, we will substitute these values, P1, V1, T1, and V2 and T2 in respective places, and simplify Eventually we get this 1.86 10 to the power 5 Pascal. So this is very important. And so in the next question, a certain quantity of gas has a volume of 40 centimeter cube at a pressure of 2 into 10 to the power 5 Pascal at 27 degrees Celsius. Find its temperature. So we have to find the temperature this time when the volume is 30 centimeter cube and pressure is 3.2 into 10 to the power 5 Pascal. So V1, P1 and T1 is 27 Celsius is actually 300 Kelvin, and we have to find T2. V2 is the given, P2 is given, this formula is same, and now this time we have to find this T2. So rearranging this equation with respect to T2 and substituting the places, the values, and we have this 36 Celsius, and we know that T2 is equal to minus 273 plus 360, so 87 degrees Celsius. So in terms of centigrade, if we want to find the value in terms of centigrade, because this is centigrade, so we will simplify this in terms of Celsius, and this temperature is 87 Celsius. This is very important. And test yourself on page 96. In terms of particle motion, describe the effect of pressure on a fixed mass of gas when the temperature rises but the volume is kept constant. So this is called pressure law, and the pressure of a fixed mass of gas is directly proportional to its absolute temperature. The pressure increases with the increase in temperature. So this is pressure law. Describe in question number 6, describe the effect of a pressure of a fixed mass of gas if the volume is reduced. Effect on the pressure, we have to find the effect of pressure on the fixed mass gas if the volume is reduced but the temperature of the gas is kept constant. Variation in gas pressure. So this is called the Boyle's law, and if we increase the pressure, the volume will be reduced. So the Boyle's law is stated as the pressure of a fixed mass of gas is inversely proportional to its volume if its temperature is kept constant. So if we double the pressure, here the pressure is at this point, the volume is this. If we increase the pressure, so the volume will be reduced to this half value. Here this volume is suppose 10, here we have a 5. So here the pressure is P1 and here we have P2. So the pressure is doubled, the volume is halved. And similarly 1 over V and P is directly proportional, as we said earlier. So why minus 273 chosen as a starting temperature for the Kelvin scale of temperature? The volume temperature and pressure temperature graph of the graphs are this given, and this shows the linear expansion, and at this temperature we assume that the internal energy of the matter becomes 0. So that because it is the 0 for the absolute Kelvin of temperature, absolute 0, the molecular motion ceases and substance has no internal energy. At this level, the temperature has no internal energy. So this is very, that's why we choose this as the starting temperature, below which nothing will happen, because this is the minimum theoretical temperature possible. And how do the size of unit of Celsius and Kelvin scale of temperature compares? So minus 273 Celsius equal to 0 Kelvin. So 0 degrees C is equal to 273 Kelvin. 15 degrees C is this. So that's why we generic equation is obtained as T is equal to 273 plus theta, where theta is the temperature in Celsius and capital T is the temperature in Kelvin. In the next session, we'll discuss